Hello, this is Jace Fugate with the Introduction to the Go Programming Language courses. So let's go ahead and jump into the numeric types in Go. So go get into your Go path here, open up the source subdirectory, and let's create a new subdirectory inside the source subdirectory. Create a new directory in there. We're going to call it numbers. And just like the Hello World program that we have right here, we're going to create a new file. Let's call it main.go. So let's go ahead and give this the package name main. Again, this is the entry point to our program, so we want to have a main package. Let's write our main function. So you got func space main, the parentheses, and the open and closing brackets. And so in Go, when you create a variable, or if you don't know what a variable is, it's kind of like a bucket where you can store things. And in Go, because it's statically typed, once you say this bucket can hold this type of thing, you can't change that. So we're going to type the word var for variable. And then you want to give it a name. Let's say my, 8-bit number, my 8-bit. So we're going to make an int 8. So that's an 8-bit signed integer. As it says here, it goes from -128 all the way up to 127. So we can say now equals 10. So there you have it. Now if anywhere in my program where I use my 8-bit, that means 10. You can't go in here and say, you know what, I want my 8-bit to equal hello. It won't like that. The program won't compile because it has to be a number. So you can change it. It's variable. It can change, but it has to be an 8-bit, something that looks like an 8-bit integer. But there's other types here. So let's make an integer. So let's say var int, and we could type like that. And if we could type int, or if we wanted to, we could use something called type inference. And we can actually just omit that int, and Go will automatically say, hey, if it looks like an integer, I'll just make it an integer. That's the default type for a number. So we'll leave it like that. Now we also can use an unsigned integer. So let's make another variable, and we'll call this my uint. In fact, let's keep with this naming notation here. Int 8. So uint, and it gives us a whole lot of different options here. We have a 16-bit, 32-bit, 64-bit, and 8-bit. The larger that number is, the bigger the number it can store. Let's just do a regular uint. And let's make this 15. So we couldn't do -15 because it's an unsigned integer. You can only hold positive numbers here. Make another variable and call it my hex. So my hexadecimal. So we're going to put a 0x or 0x. And see how it turns red there, just letting me know that, hey, you're typing in something special. So this is a hexadecimal number. And that 0x is a prefix that tells Go when it compiles, hey, this is a hexadecimal number. So let's go ahead and jump on to another one. So let's say var my octal. So this is going to be octal notated number. There we go. We also have some things called floats. That's what you think of as like a decimal. So we have a float 32, a float 64. Either way, again, the bigger the number, just the bigger you can, the larger the number can be. So let's just do a float 32 equal 9.3. And we can use type inference again here. We can actually say, just omit the type, as I did here. So we can actually just omit the type down here. And Go will just say, hey, I know it looks like a float, So let's just call it a float. So now if I type in here my float, it recognizes that as a symbol. So we can go ahead and run this, or try to run it. You'll see what happens. It's going to yell at me. Oh, let me make sure I jump into the correct directory here. Go run. Oh, give me a bunch of errors. It says that all these things are declared, but they're not used. In Go, if you don't use a variable, it's mad at you. It doesn't want you to be wasteful. It doesn't want you to say, hey, here's a bucket and store some data in here, but then you never actually use it because that's just a waste of memory. So let's use our handy dandy fumped package. We're going to use a different function this time. It's going to be printf. I'm going to go ahead and save. Again, if your text editor doesn't automatically import that, just go ahead and put that in. And let's print out all these numbers. So we can actually use a special notation in Go for all of these numbers. So the D is for numbers, for just like your integers. And then we can use a #x for hexadecimal. You can do, again, these all are prefixed with parenthesis, didn't say that. But the special format strings are prefixed with a parenthesis. O for octal, and then F's for floats. Let's put a new line here. Let's see here, my int, my uint. Type all these in. Oh, look at that. There we go. So now if I run this program, it'll print everything up for me. So here we go, 10, 115, you got that hex number, this octal number. Sec. Then 9.3, 5.6. There you have it. These are the basic numeric types in Go, and you can do all sorts of math with them, and we'll go over that more in some of the other discussions. Thank you so much for being here.